Now, I am delighted to introduce this month's presenter, Dr. Travis Longcore, who grew up under the northern lights of eastern Maine, where he played ice hockey, soccer, and studied trombone. Tonight, I will be the one tooting his horn. He then went to the University of Delaware, followed by UCLA, where he earned an MA and Ph.D. in geography. He is now Adjunct Professor and Co-Chair of the Environmental Science and Engineering Program at the UCLA Institute of Environment and Sustainability. His research is focused on nature in cities, and his landmark article, Ecological Light Pollution, and 2006 co-edited book, Ecological Consequences of Artificial Night Lighting from Island Press, have come to define a rapidly growing research area in ecology. In 2022, he received the Galileo Award from the International Dark Sky Association in recognition of outstanding achievements in research or academic work on light pollution over a multiple-year period. An accomplished environmental policy consultant, Dr. Longcore, has been sought out to provide expert commentary and analysis in dozens of environmental cases for organizations nationwide on numerous critical issues, such as tower kill of migratory birds at communication towers, the ecological impact of pesticides on birds, and the proposed delisting of the Yellowstone grizzly bear population. He is serving his second year of duty as the president of Los Angeles Audubon Society, which started in 2020, and he's currently the president, and he previously served from 2010 to 2015. There is so much more I could say about his accomplishments, but to allow more time for his presentation and the Q&A to follow, I give you Dr. Travis Longcore, who will be presenting on light pollution and terrestrial wildlife research into practice. Please be sure that your microphones are on mute and that your video is turned off. And please remember to place your questions for Dr. Longcore in the chat. Dr. Longcore, you can now share your screen.
There we go. Well, thank you for thoroughly embarrassing me. Appreciate the research and the opportunity to, through the wonders of the internet, be able to speak with you in Florida here this evening. So what are we talking about? Light pollution. It's about being able to see this, the almost undisturbed night sky. This happens to be the north rim of the Grand Canyon. It's a picture looking up using a hemispherical lens. And so our horizon is all around the edges. You can see there's a little bit of light pollution there on the upper left. That's what's going on. But pretty incredible experience for anybody who's been able to have that pleasure and be able to see deep into the depths of space. If you get outside of Los Angeles, this is the same camera, but a much shorter exposure. You can see a little bit of the Milky Way. This is out in the mountains that are just west of Los Angeles, maybe about 30, 40 miles from downtown LA. And you can tell just how much light is washing out those stars and really bright there on the horizon. The one direction where it looks a little dark, that's toward the ocean, and there's very little lights in that direction. If you got into near downtown LA and got a little bit of cloud cover, it would look like this. And this is an even shorter exposure, and the lights are reflecting it. And this is a site where probably it never gets any dimmer than the full moon naturally would illuminate the ground. So it's a place where lunar cycles have been completely eliminated from the environment through the reflection and scattering of light in the atmosphere from the LA region. And this topic is something that is, I think, completely intuitive to people once they start thinking about it, which is that just as you don't particularly like light shining in your eyes when you sleep, there's a whole other side of life on the planet that happens at night and requires the cycles of the sun and the moon and the seasons in order to function properly. And so we got working on this back in the 1990s. My wife, Catherine Rich, and I, we wrote that, we did a conference back in 2002 at UCLA about ecological consequences of artificial lighting at a time when it wasn't really thought of as being a real thing. And folks had outside of the obvious examples, such as birds attracted to lights, which was well known, and turtles attracted to lights, which was well known, there wasn't so much of a synthesis across the many disciplines. And so out of that and the work that we've then been able to do, book and articles and research since, has turned into this ecological area that I'm always trying to push into practice. Meaning what can we do, not just to learn about these disruptions of the world, but how can we fix them, and what are the limits to doing that and the opportunities that we have. So we'll start here by going over the main areas and ways in which light at night affects ecology. I'll have some examples from birds, but across the kingdoms. And then we'll talk a little bit about mitigation and how you can fix these issues and how you go about it, and share some tools that you can use to analyze light in your area. So I divide the impacts of light at night up into 4 general categories: attraction and disorientation, loss of connectivity, so fragmentation that comes from perhaps those behaviors regarding light, and then ecological interactions, disruption like pollination and predator-prey relationships, and then finally all of the cycle disruption, circadian rhythms obviously being the daily rhythms that pretty much every organism that doesn't live deep in a cave or at the bottom of the ocean has, but also lunar cycles and seasonal cycles, which are based on perception of light as well. So I'll give you some examples of each of these. And those of us who work on birds, this is really a familiar topic because you can go back 100, 120, 150 years and find examples of lights attracting birds, especially during migration. These are lights attracted to the Eddystone Light. It's a painting from 1912. And of course, this is not good for the birds, and they will be often exposed then to collisions with glass and other things, drawn off course, not doing what they need to be doing in terms of getting to their destination. I'll show you a quick video of what this looks like from Chicago some years back. And these are birds that are just circling around the top of this building. You can see them go around these little flecks up there. That's migratory birds. They migrate at night because, well, they got to eat during the day and it's cooler at night. But lights like those produced by humans, and fires do this to some degree, but not the extent, are a completely unnatural stimulus to them and attract them off course and gather them into points. And we know this now with some degree of certainty for reasons I'll discuss in just a second. What happens then? They end up in cities, in towns, in industrial areas, and they're prone then to either not having good food around or running into glass. So lights plus glass equal dead birds on the ground, which is what we see over on the left-hand side, those being some birds that were actually collected in New York after migration events. And these events can be quite large, tens, hundreds, thousands across the city. And as you probably know, there are volunteer groups around the country that encourage people to turn lights off during migration and also rescue birds that are waylaid during migration and release them out or try to rehab them if that is possible. We know this is happening with some great certainty now because of the use of radar ornithology, which is taking our weather radar and analyzing it to identify the bird size specks. And we think about radar as seeing rain, but it also sees birds. It can actually see insects. And so we have these massive databases now of real-time information about bird-size items moving through the sky, and can predict and measure even the migration going through a location. So this is actually a Monday night over the state of Florida, 3.9 million birds moving over last night. And it also, so you can go here as Birdcast, I think it's .info. It's Kyle Horton's group at Colorado State in conjunction with Cornell Lab of Ornithology, and it will tell you everything that you might want to know about it. The height of the birds, the number of birds through the night, their direction, the recent history, total number of birds in the season, the altitude, etc. Absolutely incredible stuff that we now know with such a high degree of certainty because of the use of radar ornithology. This technology has also been used to show that lights actually attract birds. This was shown with the tribute in light in New York, where the number of birds within, I think it was a kilometer, increased by thousands within 15 minutes of those lights going on. So it's not a matter of just intercepting the birds that are already on a track. The lights are attracting birds and taking them on migratory routes that they would not otherwise go. This has been shown not just for the tribute in light, but also for cities across North America. We've fundamentally altered those migratory pathways by the amount of light that we put out there. This leads to other things with light. This is a map from some work that colleagues and I did in 2012. These are all communication towers. Communication towers can be quite tall, up 1,500 feet, approaching a half a mile tall. And this is the concentration of them by height across North America. And you can see for your local interest, there's a ton of very tall communication towers that are lit in Florida and the sort of southeastern coastal plain. And those towers are all supported, the tall ones are all supported by guy wires. And historically, they were all lit with solid red lights and red flashing lights. And any of the solid lights are pretty much going to attract birds. And so the number of birds killed by our estimates and calculations, parameterized by a whole bunch of things that I'm not going to go into right now, is actually the highest in the Gulf Coast and Florida as bird conservation regions, which is what those numbers are there. And this is a lighting issue. You can reduce the mortality at communication towers by about 80% by switching to flashing only lights as opposed to solid and flashing lights. And in fact, as a result of this research and the research on the flashing lights, which was done by Joelle Gehring, who now works for the U.S. Fish and Wildlife Service, there have been changes in policy for the lighting of towers to encourage operators to go from solid lights to flashing only lights. Took 7-8 years, but we finally got that done. This is also not just an issue for nocturnal migrants. It is one for seabirds that are trying to get out to the ocean as fledglings from their burrows. This is Corey Shearwater from research that's done in islands off the coast of Spain. And if you watch the course of each one of these is I'll get this one going too. There we go. Is the route of a bird trying to get to the ocean. And the left side is the lights and the right side is the map. You can see where the ocean is. And I think they tracked 9 fledglings using GPS trackers, and 2 of them made it safely to the ocean and the other 9 ended up on the ground. This is a problem because they can't get aloft very well afterwards. There are predators and roads and cars at these locations where they end up. And so you have to basically organize people to either turn off lights, yes, but also rescue them and pick them up and toss them off a cliff off to the ocean so that they can do what they need to do. This happens wherever there are seabirds that are nesting and fledgling. The puffins in Iceland are another example of that. The high schoolers take off time when they get old enough to go out in the middle of the night and pick up pufflings, rescue them, and send them out to sea as well. Sorry, go on. Another example of orientation and disorientation is, of course, the one that's most familiar to you in Florida, that of sea turtles. And all it takes is a light that it makes the landward side brighter than the ocean side, and you end up attracting hatchlings. This particular picture happens to be in Mexico. These lights wouldn't be legal next to the coast in Florida, I don't believe, given your regulations on spectrum. Turtles don't see as well in the yellow and red, and so there's some color limitations. But basically, you can even have sky glow that will disorient hatchlings from going in the correct direction. Anything that basically reverses the normal pattern of light and dark on a beach, which is that the darkest horizon is the landward horizon, that will confuse our hatchling turtles. Insects, of course, everybody kind of knows about insects being attracted to lights. I'm just showing you an example here from some research that we did with the Smithsonian in the Peruvian Amazon. That's one of our colleagues at the research site underneath a light that has been installed in an area that has never in the history of the world had artificial light in it, and is surrounded by intact lowland rainforest. You can see the quantity of insects there. Our task was to design lights or recommend lights that would reduce that attraction some, and we were able to do it, but there's no making it perfect. We could reduce attraction by maybe 30-40% by the spectrum of light that we used, and the fellows on the right are demonstrating our experimental setup there for that particular study. But this attraction, of course, is something that we're all familiar with if you've ever been outside at night. What are the consequences of that then? Well, it's disruption of ecological interactions. So attraction and repulsion and disorientation, this first category, also affects the interactions between species. Pollinators, we think of it being a daytime thing, butterflies and bees, but it's like half of the pollination services are going on at night. And so we have all sorts of things that are not happening if those species are being influenced by lights. And again, we have incredible studies now from around the world using night vision goggles to track pollinator visits, documenting the decrease in seed set from nocturnally pollinated species, spillover effects then onto daytime pollinators, because if you disrupt the nighttime pollinators, the plants don't set as much seed, you don't have as many flowers, and you then don't have as many daytime pollinators. So there's really incredible work going on there. Predator-prey relations are another place where you get disruption and as a secondary impact from the lights. So this is an example of some work that my colleagues and I did in Southern California, looking at Western snowy plover, the bird there, and then California grunion, which is a fish that comes up onto the beach to spawn. And it does this during the new moon and the full moon. It's a big thing. If you've ever been to LA, Southern California, to actually go out and see the grunion runs. But it happens on the new moon and the full moon. And the plovers are rare, in fact, listed under the Endangered Species Act. And we have these big data sets of where they're active in Southern California. The blue dots are the plover roosts, and the yellow dots are the grunion runs. And then we have a bunch of environmental layers. We went out and measured the light conditions on sandy beaches and created a model, which is the sort of second thing here on the left. The brightest area corresponds to right here, Long Beach. That's the port of LA, super, super bright. The darkest areas are out here in Malibu and up into Ventura County, the county north of Los Angeles County. And so we have a lot of data. put together and did some math with it and showed that there was actually a threshold for both of these species for the probability of finding them a roost for plovers or spawning grunion on the beach. The threshold for a decrease for the plovers is about half of a lux, and that's about half the brightness of a typical full moon. So you get brighter than that, and you're much less likely to find plovers. On the other hand, if you look at the grunion, we're actually finding them a bit more, or at around 1/10 of a lux, which is the full moon illumination, and then decreasing after that. It made sense because the grunion are used to spawning when there is a full moon, so the full moon illumination isn't a problem for them. Too much light, though, is probably going to affect them in terms of predators. So our interpretation of this finding for both of them is that this is being governed by predator-prey relationships. The plovers are looking for dark places to hide because, let's be honest, they're tasty little morsels that there are plenty of things would like to eat. The grunion, they do a little bit of swamping the predators all at once, but birds do line up to eat the grunion during the grunion runs. And if it gets too bright, it's probably a bit too easy for them there. So that would be an example of predator-prey relationships. Other things, again, probably dealing with predator-prey as well. Black-tailed godwit, this is a European species, has decreased nest density up to 300 meters from street lights. And the godwits that get to the nesting ground first take the spots that are furthest away from the lights, and the ones that get there last take the ones that are closest to the lights. And we're pretty, it's consistent with an interpretation that it is predation risk that they're worried about. They're worried about being able to be seen under the lights. Then we get to another phenomenon, which is the fragmentation of landscapes from lights. This is a famous mountain lion in Southern California. It was lived for, I think it was 8 years, I guess, around about that, in our largest urban park in LA, Griffith Park. But there's a bunch of information that suggests that mountain lions, and probably your puma in Florida as well, don't like to go near lights. And in fact, that lights can be a barrier to getting across landscapes. And those lights go along with the barriers being dangerous for other reasons. This is a large open space that goes out to the ocean here, and I'm standing on the other side of a major freeway. And that light is a barrier behaviorally for mountain lions and other species that are kind of wary of light. And of course, it's also very dangerous because there's the traffic. But even independent of that, we've now shown using large data sets from radio-collared mountain lions a tendency to avoid lighted areas within their range. And so if we want to get mountain lions eventually from one side to the other, well, in this instance, we have to build a bridge for them. They're doing that right now. And we have to create a path for them that is dark. Quiet too would help, but definitely dark to stop that fragmentation of the habitat. This is another example of fragmentation from light pollution, the Sundial Bridge. This is a salmon river in Northern California. And so again, I'm cheating here as an aquatic species. I promise terrestrial ones, but fish are highly influenced by light in terms of their activity, and the movement, the out migration of the juvenile salmon is affected by light at night. So this kind of light, where you've basically created a complete barrier across the river, probably wasn't thought about twice by the architect. It was like, this is a really cool architecture and I'm going to show it off at night. And didn't really consider that this is actually just the same as putting a wall in the river for some species. This has been shown for mayflies in Europe, how bridges can be barriers. The lights on bridges are barriers to mayfly. Genetic connectivity is an influence to salmon as well in studies around the world. Then we get to cycles and rhythms. And so this first example is showing the influence of day length on soybeans. This is a soybean field. It happens to be from northern Georgia. And you can see that there's this sort of circular, half circle, semicircular area that's dark green, and then a lighter green, and then the rest of the field. Well, what happens is the soybeans set seed when they detect that winter is coming. And if they don't think winter's coming, they just keep growing. And the soybeans that are next to this street light right here haven't gotten the signal that winter's coming because of the light from that street light. And you can tell that's what's going on because you can actually see the shadow of the head of the street light right there. There's a dark spot. So those soybeans right there know that winter's coming, but the ones on either side don't. And these that are closer, or it's even brighter, really don't know that winter is coming. And so this is an example of light giving a signal of timing that then influences the physiology in this instance of an organism. And it can influence behavior as well. I know we have the purple martin queen on the call. There was a study 2 years ago, I want to say now, looking at the timing of migration of purple martins. And it is heavily affected by the artificial light at night at the location of the wintering grounds. So that how early your martins are coming or late is being influenced by the amount of light pollution that is at their wintering grounds. And just to give you another example of this is a tree that is confused by the street lights. Half the tree thinks it's time to flower, the other half thinks it's time to grow. That's absolutely, you can see this all the time. Plants that hold their leaves on too long, flower at the wrong time, etc., under street lights. And it can be a significant economic issue, for example, for the farmers that are trying to harvest through that entire field and get their money out of that investment. The green ones under the street light, there's no economic benefit to them. There's all suite of other physiological responses to light at night in terms of daytime, day length, breeding time, etc. I'll just give you some examples. Street lights can be used to induce laying in birds. This is used in the poultry industry extensively and goes back to the 1920s and 30s. Shown again in the wild of breeding behavior in the 60s. Foraging times during the day in birds. There's a whole suite of studies from hummingbirds in the tropics to hornbills, etc. We've got tons of examples of this. Lay date affected, timing in migration, the purple martins being one example. Molt progression is affected by light at night, dawn chorus and daily activities. Great study a decade ago about American robin dawn chorus. And so there's just, study after study that shows us these impacts. And for many of these, we don't know yet what consequence this necessarily has for conservation or evolution, but we're getting there, right? So the study that at the top here, streetlights turn young duds into studs. What happens there is that for blue tits in Europe, the females will mate with the males that sing the earliest in the morning because they have good territories and they're very robust specimens. And young birds typically don't sing as early in the morning, but young birds in marginal habitat, young males in marginal habitat next to lights, because of the lights, they sing early. And then they start getting matings from the females. So that's actually affecting the mating system. And you don't then have what they call an honest signal of what the most fit males are going to be when you have young males. They're basically on light drugs that are attracting females because they're getting up early and singing because they've been disturbed by the lights. But the females think that that's a sign that they're particularly healthy specimens, shall we say. Just give you another example about this on seasonal ones. This is one of my favorites. This is a reindeer in northern Sweden and other areas in polar regions. It has a complete adaptation of its eyes from the wintertime to the summertime. In the wintertime, the eyes are blue, and in the summertime, the eyes are yellow. They basically are trying to capture as much light as possible in the winter, and then they put on essentially blue blocking sunglasses in the summertime, and there's a physiological change in the eye to the yellow. This was discovered when people were looking at reindeer eyes from slaughtered reindeer and just started noticing that they had these different colors. They've also found green eyes, and green eyes are from this particular example was from reindeer that were kept captive, not even under a street light, but over the hill from a street light in northern Sweden. And that was enough so that their eyes didn't completely adjust from the yellow to the green in the wintertime. So again, there's just tons of these kinds of examples where lighting is influencing from, attraction, disorientation resulting in death, fragmentation that's going to affect the viability of populations, predator-prey relationships and pollination relationships and ecological interactions that will affect species composition and communities, and then daily and seasonal and lunar rhythms that will also affect individuals and their survival. And what I haven't mentioned here, of course, is in this last category of the physiological impacts, we humans are affected as well, including excess exposure to light at night being presumed to be carcinogenic with increased incidence of certain hormonal cancers that are related to our circadian rhythms, such as breast cancer and prostate cancer. So I want to switch now and talk after that a little bit about vision, because we're going to mitigate. We need to think about how light is perceived, and what you might do in order to make things safe for people, but avoid impacting other species. And this is not my graphic. I have nicked it, but it really illustrates quite clearly that in the example of deer don't see orange and red like humans do. We see long and orange and red are longer wavelengths. Blue and violet are short wavelengths of light, because light's made up of all the different colors of the rainbow. And deer don't see it all. And so if you wanted to have a light where we as humans saw it, but deer didn't, you would want to use red light. And so that, and I'm going to go into this in a bit more detail, but I just want to sort of introduce this as the overall concept of things that we as humans see well that other species don't see as well. Now, that said, there is some light that other species see that humans don't. So ultraviolet light, which we as humans don't use in our visual system because it gets actually filtered out by our cornea, insects use, and other groups do. Mice use it. Bats see into the ultraviolet. There's a whole bunch of groups that see into the ultraviolet and therefore are seeing colors based on their visual system that we as humans don't. And now the thing that you're going to immediately think from that is, well, we probably shouldn't use those colors if we don't want to affect species at night. And that's absolutely the case. And this is like the easiest one. But historically, we had lights that had ultraviolet in them, even though we weren't using it for our vision. It was part of the chemistry and physics of the way that the light was produced in something like a mercury vapor light, if anybody remembers them from 50, 60 years ago. So insects, do see a lot in the ultraviolet. Now, how do we go about assessing how good or bad a particular light might be for any particular outcome? And so I've got a series of graphs that are like this that put together three things. The first is a response curve based on the color of the light for different things. And the first thing is for humans. So this curve in the back is the sensitivity of human vision to these wavelengths of light. We see really well in the green into the yellow. This is the sweet spot for human daytime vision. The back along here, this color, that's the light that is emitted by the sun. And so that's all the colors of light that are in sunlight. And then the pastels in the front are the overlap of human vision with the emissions of light from the sun. So the size of this area that's in pastel is roughly equivalent to sort of how bright or how much of an impact a light with those characteristics has for the system that we're looking at. I hope that makes sense. So we got human vision, we've got the spectral content of the sun, and then we have this overlap between them. And so this light is compared with now a high pressure sodium light. So a high pressure sodium light is the old orange street lights that were the thing that you had probably before people started converting to LEDs. And so that sort of orange glow was a high pressure sodium, and it had a lot of orange light and red light, some yellow, a little into blue and whatnot. And you can see there's plenty of overlap. It's plenty bright for us to see with. There's not a lot of blue and ultraviolet. The other thing I should explain here is something called correlated color temperature. This is a summary number for how much blue or yellow is in the light. A low correlated color temperature has a lot of red and yellow. A low one has a lot of red and yellow, and a high one has a lot of blue. And I'll come back to that in a second. So there's your spectral output, there's your vision, there's your overlap. Now we have our LEDs that come along, light emitting diodes. They're highly effective. Everybody's switching to them, energy efficient. And for sort of technological development reasons, the first lights that we get have a lot of blue in them. So the LEDs have this peak right here. It's called the pump. It's a blue pump. It's the LED diode that then has a phosphor on it that absorbs that blue light and reflects it out over the other. So we've got our human vision in the back, and then we've got all these emissions in the blue, and then a bunch over here. And we see great under this. It's 4,200 Kelvin. It's got a lot of blue. Here's a 2,200 Kelvin LED, much less blue. They're taking a lot of that energy and tossing it over here. Still plenty of light for us humans to see in. There's another curve, melatonin suppression. Humans and pretty much everything else create melatonin in the dark. It's a hormone that's useful to regulate our circadian rhythms and do other things like keep us from getting cancer. It keeps cancer tumors from growing. So producing melatonin at night is incredibly important to our health and our circadian rhythms. And it's sensitive to shorter wavelengths than the daytime vision. Remember, our daytime vision peak was over here. Melatonin suppression is over here in the, well, basically the color of the sky, blue. That makes sense. A blue sky is a great signal that it's daytime, and over history, you know, that's the thing that tells us that we shouldn't be producing a hormone that gets produced at night. So if you're getting it during the night, it's telling you that it's day and you're not producing the hormones that you need. High pressure sodium doesn't do that so much, right? 4,200 Kelvin LED does it a bit more. 2,200, a little bit less. So these interactions between a response and a spectral output of a lamp or something in nature help us to predict what the impacts are going to be. We also have some things for other species. This is an attraction curve for moths. They like the short wavelengths. They like ultraviolet, they like blue, super attracted. So this is daylight, 6,500 Kelvin, and moth attraction. All this area in here is stuff they're responding to. Much less attracted to a high pressure sodium light, more attracted to a 4,200 Kelvin LED, less attracted to a 2,200 Kelvin LED. And you can see now how we put them together. When I first started doing this, we had about 12 of these curves that people had put together to figure out impacts on wildlife. I went back as part of a project for California Department of Transportation and scoured the literature for the last 60 years and found about 170 curves. So all the lines on this chart here are lines of sensitivity for different species of terrestrial wildlife. And this line through the middle is sort of the average of them all. And what I want you to notice is that the peak for human visual sensitivity is over here, and we see pretty well over into the orange and the red. And this line goes down more rapidly for other species here toward the yellow and the red than it does toward the green, and especially as you get down into the ultraviolet, where humans don't see it at all, and other species are quite significantly affected by it. We can look at this across different groups of organisms, including birds. So here's our friends in Audubon, the birds. And what can we say about them? They have pretty broad sensitivity. So birds actually aren't as easy to mitigate with spectrum than some other things. Insects a bit easier to mitigate than birds. But we take all this, we put it together, and this is how we get to making recommendations about the wildlife friendliness of different lights. This is that correlated color temperature I was telling you about before on the bottom. Lower color temperatures have lots more yellow, higher color temperatures, lots more blue. This is average wildlife sensitivity. These are a bunch of real life light sources. High pressure sodium, low pressure sodium, which is basically just yellow light. The full moon is up there, which is redshifted a little bit from daylight. And what the overall message here, though, is lower color temperatures, more yellow and red, better on average to reduce impacts to wildlife. It doesn't work for everything. I will tell you this, because some species are doing all of their visual communication in the yellow or the red, like fireflies. So you just got to keep fireflies in the dark. No light is good for them. But on average, if you wanted to reduce impacts, you want to go with lower color temperatures, which leads us to how do you go about doing all this? First, light only where you need to. Turn lights off when they're not in use. It's like use motion detectors or motion and heat detectors. We do this now in our parking garages at UCLA. The lights will go down to actually a lower level, and then when you move or go onto the floor, it will light it up at a higher level. Saves energy, reduces the amount of light pollution. You make it only as bright as you want, direct it where it needs to go, and then based on what we were just talking about, use the lowest possible correlated color temperature for the goal of the lighting. And these apply to everything. You can reduce your effects on turtles, on birds, on insects, pretty much everything. These rules work. Only, one exception is for bioluminescent insects that are attracted to things in the yellow and the green. That's a special case. But beyond that, these are the rules. It's just a matter of getting people to do it. We put these up there in a graphic form for the visual learners. Part night lighting, that's turning the lights off when they're not needed, or using a motion detector, shielding them so that the lights are low and on the ground. You have some great educational materials in Florida about this because of the sea turtle issue. Spectral control, going towards yellow and red as opposed to full spectrum and blue. Dimming all the time, and or dimming on a timer, and or reducing intensity general. These are the strategies that work across the board. So question, do you need to do something there in South Florida? Yeah. So this is from a website called lightpollutionmap.info, and it is a depiction of the World Atlas of Artificial Night Sky Brightness. And the brightest areas are this color right here. The darkest areas you don't even quite get to out here in that gray. So basically all of South Florida, as dark as you get, it gets pretty good out there in the national parks, but it is still influenced by the lights of South Florida. And so this is just showing us from 2015. This takes into account the scattering of light in the atmosphere. And then, but this product isn't available on a year-to-year basis, so we can't track progress. There's another satellite up that does. You can track progress with. I've zoomed in a bit here on Miami and into the Everglades. And this is an annual composite where we have a satellite up there that's going over every night, and then they sort of average it out for the year. And you can see that there's some areas where it's showing light that there aren't any lights on the ground. That's because it's actually measuring the sky glow. That you've got to be a very sensitive satellite to do this, but it does. As you get further out past the sky glow, you can still see the individual lights on the ground. So that's available for you also at lightpollutionmap.info. But what I want to show you here for a second is a subsite called Light Trends. So it's lighttrends.lightpollutionmap.info. And let me see if this works. If I switch over here, close that. It takes us here. So this is radiance light trends at lightpollutionmap.info. Here's where things get fun and we do things live. You can pick different layers that you might want to look at. So right now that's the 2021 data from the, well, it's the satellite that measures light at night. You can go back in time. You pull up the 2020 imagery. If you go back earlier than 2017, they processed the data differently. And so this looks like it's much darker. It's not. That was just a change in the way that they processed the data. And that comes out in the tools that they have to analyze this. But let me do something here for you. And let's just pick a spot out here. Maybe on the way out, some junction here, there's a tool. So you select a spot and you make a polygon around it. And you basically, what we're going to do here is we're going to say what happened to that location over time. And we're just going to use the defaults here, but we're going to generate a chart. And so on a real-time basis, it's going to go and query the satellite data that's summarized by month and then fit a line through it. And what you can see happened here is wherever this location is, I think it's on the highway heading out into across the state, somebody relamped right about here. Something happened and developed. That's a real change and an abrupt change for this small area in the amount of light that's escaping, which also means the degree to which this is going to affect birds, the degree to which it's going to expect that are on migration, anything in the surroundings. And you can go do this wherever you might like to do it. So I think I popped one up here. I had already pre-done this. I think this is somewhere near where your headquarters might be. And you'll correct me later if I didn't get it quite right. But make a chart. And you can see that there's been a steady increase in the amount of light emitted from this area since 2013. Before that, we do have data, but they're from different satellites and they're not as comparable as this. There's also a challenge with these data. I do have to let you know, this satellite doesn't see blue light. It only sees green and yellow and red. And that means you can actually have a much worse situation than the satellite shows you if you've been converting from high pressure sodium to LEDs, which have a lot more blue. And so it's a real tragedy that the satellite was designed that way, but this is even in blue light blind, you're still seeing this impact here in terms of increase. I did a similar thing like this for Havana just this afternoon, and it turns out Havana is like just a straight line across. It has not been increasing its light emissions over time. So I find this to be really super helpful to help people understand both the distribution of light pollution and quick assessment on trends. I was given a talk to a community group in Baja, Mexico, Baja California in Mexico, not too long ago. And they're like, hey, we noticed that there was a relamp of this hotel that's down on this end of the beach. And I said, okay, well, let's go find it. And we looked at it, and sure enough, exactly when they said, the change of lights of a single hotel was visible in the data set. And that then gave them the tool to go back and hopefully do some outreach to the hotel and say, hey, we understand what you want to do, but this is, releasing light upward that isn't useful to you. And this is the whole point. And I want to go back here to the slides for a last little sort of not what you normally expect in a bird talk, because this is like mundane landscapes of lights at night. But instead of showing you the worst lights in the world, I want to show you some examples where people are really trying. So this here is an example of a motel, where the lights are full cutoff. There's no light going up. They're under an overhang, and they're yellow. So it's got your warm spectrum. It's not too bright. It's full cutoff. And I think we have to share more and more examples of things like this that are just the normal everyday landscapes that are perfectly safe, but reduce the amount of light that's being wasted from them and going other places. And these are from my colleague Debbie Moran in Houston. Just an example. Is it perfect? No. Is it better than your typical suburban strip mall? Absolutely. Warm colored lights, full cutoff, not glaring into drivers' eyes, low lights, lights that are fully shielded, warm looking, right? Warm colored lights, fully shielded. I might change these out for something else because that's full spectrum white. There's holiday lights there. That's a whole separate discussion. I try not to rain on people's religious celebrations, but you tend to want to limit them to a number of weeks if you can. Again, in the field pictures by amateurs being sent in, just comparing between a full spectrum, very blue light and a yellow light. And what do you notice here? All the insects are at the blue light and they're not under the yellow light. Again, low, warmer colors. Is it perfect? No. Are these examples that we can show to people who have bad lighting and say, can you make it better like this? Absolutely. And so that's the purpose of outreach on these things. Once you show them the beautiful night sky and how it affects birds and how things get killed and all these disruptions, but to just show that we're not asking people, especially in a commercial environment here, this is a hotel patio with a restaurant, that we're not asking them to turn everything off, but rather do it better. And that's going to be better for the birds. It's going to be better for the people. It's going to be better for the turtles. It's going to be better for your nature. So I'd like to maybe end there. This is Flagstaff, which did a big relamp. Again, they're very conscious of light pollution because they have an observatory that contributes quite a bit to their economy. They did a big LED retrofit, and in the process, reduced the light pollution from the city because they did it right. And it was better lighting that lit the things that needed to be lit when they needed to be lit, instead of the undersides of birds and airplanes and washing out the night sky for us. So that's LA on the 4th of July, and a little example of the extent of our lights, pictured by my former student Ben Benet. And I want to thank you and take your questions. And I hope that this was a reasonable mix of birdie things and practical things to do as you think about light in our environment.
Well, thank you, Dr. Longcore. That was very informative and very disturbing at the same time. The information was, I don't want to say graphic, but it felt like wildlife in certain respects doesn't have a chance. We just keep lighting the world and not lighting it properly. And hopefully some of the things that you're suggesting will not only happen, of course, in our area, but in areas all over the world. But I think that's probably, unfortunately, wishful thinking. Just some very specifics in terms of our personal lighting that we have in our homes. So I'm just going to throw out a couple of things. So LED versus incandescent, which of course is hard to get. So are you saying that we should be having LED lights instead of incandescent lights?
It is inevitable unless you've stockpiled.
Yeah.
It is inevitable in the United States that you're going to be using LEDs for your indoor lighting. LEDs, however, are available with different spectral compositions. And in fact, there are LEDs that are adjustable. I have two examples here in the room that I'm in where you can adjust the color temperature. I can do that on my my desk lamp, where it goes from a very yellow light that I use at night to a very blue light that I use during the day. There's also even ones that go in an old typical like ceiling fixture that have a little chip in there, and you turn them off and on within 6 seconds. It changes the brightness and the color temperature. So if I want it dim and warm, I just turn it off and on, and it clicks down to a lower level, and you can adjust that. So you're going to have them, and the counterpoint to all of this as well is that you do want to be exposed to full spectrum light during the day, right? It's all about the timing. And the amount of melatonin you produce at night, for example, is correlated to the amount of blue light and brightness of blue light exposure you get during the day. So going outside, getting full sunlight, having natural lighting in your workspace or things like that are all very good. But when you get into the nighttime, the general recommendation from circadian biologists is switch to warmer color temperatures, and especially as you go into the period before you're going to go to bed.
I see. Okay, so recommended adjustable LEDs if we can.
Yep.
Okay, and so that might be like a minor retrofitting of some of the fixtures that we might have in our house.
Yeah, I mean, honestly, they go right in the old fixtures. I got track
Okay.
lighting from the 70s in here, and I have adjustable LEDs in them. So
it's affordable, and it's something that people can do fairly easily, and there's probably minimal technological knowledge needed to do it.
Yep. Can you screw in a light bulb? Yep.
Can you screw? Okay. There's lots of jokes about that, but we will go to that. So I'm hoping people are putting questions in the chat for Dr. Longcore. I see some. Please put in more if you have any other questions. So I'm going to start throwing some of the questions out at you. Sue Ravi asks, any progress to cut bridge lighting?
To cut bridge lighting?
Bridge lighting, yes.
Yeah, as a general initiative, no. I think we've been raising awareness about that, and there are individual instances where we've been successful. In fact, our whole effort here came out of fighting a proposal to light a bridge in Los Angeles with floodlights that would have gone straight up and been visible from the moon as a point source with the naked eye if you happen to be up there. And so, and we won that one. We fought that back, whatnot. But as a general initiative, no, the Europeans are quite active on it in the science field because of the fragmentation issue I was talking about. And salmon people, fish biologists tend to be emphasizing bridges as well. There is, however, a trend to like light bridges up with LEDs because the energy is so cheap and we can turn it into a massive public art sculpture. And it just makes me cry, and I think it's light vandalism, but I may be fighting an uphill battle.
Wow. Disappointing. So maybe they need adjustable LEDs for those bridges. At least they can tone them down during, but they don't want to. They want to light it up at night, of course. Other questions. The bird breeding, this is from Blake Scarborough, our intern. Mm-hmm. The Blake breeding thing was interesting, how they start mating differently going against nature due to light pollution. So most studies have to be pretty recent on those effects. Evolutionary?
So I think there's two questions on them. So the reason that the research isn't that early on mating and laying is that there's money involved in the poultry industry. And so the minute people figured out from street lights that's like starlings in London were laying eggs at the wrong time of year, they started using this with chickens. And so there is this huge literature from the agricultural sciences around the use of light to produce eggs when you want to produce them, make the chickens grow, or ducks or whatever it is, grow as fast as you want. And it's absolutely astounding. I did a big review of the literature on this, and the poultry industry literature dwarfs the studies that we have on wild birds, even though the wild bird stuff came first. Are there evolutionary impacts? We're starting to get a few examples of light pollution studies that have shown evolutionary consequences. I don't think with breeding time in birds yet. But we do have it for attraction of light in a species of moth in Europe that has both rural and urban populations. The urban population has less intrinsic, genetically associated attraction to light.
Wow. Chickens. Okay. This is from Phyllis Strain. Are the LED lamps being improved for a warmer natural light in commercial settings?
Yeah, I think they're they're certainly becoming more and more available across a range of colors. And this has to do with the refinement of the technology in the industry. But you have to know to ask for it. And so there are people who specialize in, circadian lighting. There are people who specialize in, supportive lighting for hospitals. We're researching it for memory care because Alzheimer's disease, for example, has associated with it a degree of disruption of the day sleep-wake cycle. And so using full spectrum lights in the morning and warm lights in the evening in healthcare situations is being investigated. But it's not every lighting designer at this point that knows about it and is doing it. But I think over time here that will become the case.
Yeah, that would probably reduce healthcare costs as well. This is from Kevin Baker. Will covering a white LED light with a yellow glass filter be an improvement?
Yeah, so filters are a great way to go about that. In fact, there are two ways that the LED manufacturers or light purveyors do sort of wildlife friendly lighting or star friendly lighting. One is in the chip itself with the diode, and the other is with filters. So the filter does the same thing. It cuts off the blue end. A yellow filter will cut off the blue end of the emissions. It does reduce the total amount of light output a little bit. All filters do, but we're at a point where that can be like 3% or 5% of the total output, depending on the technology. So it's really a small price to pay for the benefits.
I see. And is that kind of like putting a filter over a flash of a camera?
Same thing. Yeah.
Same thing. Okay.
Yeah, or the red when you're at a star party, the red over the flashlight. The filters are just cutting out those wavelengths and letting the one wavelength of the color come through.
I see. Rachel Sire says, so good. Thank you for the info. I would love to convince my HOA to change our street lamps, which are horribly bright. Is there a presentation that you have pre-recorded with some of this information that I could show them?
I have a number of these presentations. They're never exactly the same, but there's many similar elements on my website, travislongcore.net. There's a tab for audio and video, and I think most of them are there, and also like appearances or something. There's some videos there as well. But I would highly recommend also consulting materials available through Dark Sky, that used to be called the International Dark Sky Association, because they have these kinds of things, as well as some demonstrations that I don't usually do around safety. Because one of the things that you'll want to talk about for places where there's really bright light is that you're not telling them that you don't want light. You actually want better light so that you can see better. Because when you have a very bright light like that, the human eye can only adapt to a certain range of light at a time. And if you got a super bright light, it means the dimmest thing that you can see is actually brighter than you would be able to see if your light was a little dimmer. So you can put it another way, if you can tone that down and eliminate the glare, then you can see into shadows. Glaring bright lights make it easier for people to hide because of the way the physiology of the eye works. You can't see into those shadows when you've got those super bright lights. And so you can make an actual safety argument. And there's some demonstrations that people do when you cut the glare point or you dim the lights, how somebody who was standing there in a doorway or something suddenly was invisible in complete darkness before. You make the lights better, reduce the glare, make it less of a contrast, and all of a sudden that person who was there, it becomes visible to you. So this isn't, people have this idea that more light makes you safer and that you see better, and they're not understanding how nighttime vision works. And so if you can get them over that hump without having them feel threatened, it's like, no, we got to do a better light here so that we can, have gradations between the dark and the light. That is a much better strategy, and there are some videos that can demonstrate that for you.
So better, not brighter, yeah, is kind of the key here. So and we'll be sharing this video on our YouTube channel as well, Rachel. So you'll be able to perhaps show this to your HOA board or committee, whoever makes those determinations. Blake Scarborough, again, wow, I am just hearing about this, not surprised. I'm not sure what Blake is referring to here, but maybe it's just in general. Sabina says, question from a 12-year-old viewer, her daughter, I suspect. What are your recommendations for holiday lights?
Yeah. Well, part of being successful in this is making friends. And you don't tend to make friends if the first thing you do is you say, I don't like your holiday lights. Can you take them down? At that time, people are tending to want to, celebrate. I think, and so I'm very cautious about this. However, one of the things that can, and the flip side of this, though, is you can, from satellite, track increased light associated with pretty much every major religious celebration around the world. And people have done this. It's different places and different times and different cultures. There's pretty much always a time when there's more light available. The thing that the effective way to do this is to, you can ask people to be judicious about the amount of light, but probably better is a time limits. And this is what some of the people around the Central Idaho Dark Sky Reserve that I work with in Idaho, they have, some of those municipalities have said, okay, holiday lights are from this date to that date. Go for it, knock yourself out, but not before or after. And that's one way to put some control around it. The other might be education. Say, hey, probably don't want to use the icy white ones because they're going to glare more and they're going to, scatter more in the atmosphere. But generally, I would rather have, if I had to prioritize my my goodwill in the community, I would be aiming for sort of overall better lights year round than worrying about holiday lights specifically. And I'll just and if I can respond to something you said earlier about, can we make any progress on this? And I truly believe that we can. And one of the places that it's happening is through municipal streetlight plans, because, and I just participated in one a couple of years ago for Salt Lake City, and they had originally switched to high color temperature, very bright LEDs, and they got a lot of pushback from the community. And then they put together a team that understood the wildlife issues, the dark sky issues, the tourism issues, the economic consequences of night skies. And they said, we want to do this right. And so we ended up recommending, yes, you need some more lights in some places that are underlit, and it wasn't fair from an equity perspective and perhaps dangerous, especially for pedestrians. But overall, really innovative stuff about lighting levels, about the color temperature of the lights, about creating the ability to control the lights and reduce intensity after midnight, or have the head of the street light be able to turn the lights up around the stadium downtown after the basketball game comes out, and then turn them back down later. And they went for it, completely. And now they're in the process of starting to implement this plan. And we have another project where we're going to do a similar plan for the city of Austin. And so municipal lighting systems are a really big component of overall light, especially in cities. And once you do it, then you start getting spillover effects. So for example, after this plan was adopted by Salt Lake, the developer already had his permits, was going to build this thing, was logistics center, but it was near Great Salt Lake. And we had some real recommendations about reducing lighting and color and spillage near Great Salt Lake. Contacted us, no regulations, his own free will, said, I want to be consistent with what the city is doing. How can I change the lighting on my site here and reduce the impact on this important bird area that you've identified in the lighting plan? So it can be done. Now, will we do it? Now, that's the $1 million question for all of us in conservation.
Well, that's a hopeful story, though. So I do agree, and that was Salt Lake of all places. That's great. Let's see. Oh, Blake says that was about the chickens and using lights to alter their life cycle. Yeah, I've heard that unfortunately before about chickens. Uh, uh, Nurit Cat says, great talk as always. So somebody's heard you before. Thank you for all you do,
Yeah.
Travis. Lisa Lanza, please post where we can find this video on YouTube. And Sabina did that. Thank you, Sabina. Shelley Rosenberg says, thank you for extremely enlightening presentation. Thank you, Shelley. And Kevin Baker also lists the YouTube where YouTube Audubon Everglades, I'm not sure what that is, Kevin, that you're listing there, but you are listing some kind of I guess program that's available. And I have a question also, and this was when you talked about the black-tailed godwits, and you talked about the study that was done where they established their nest on the beach relative to the distance from the lighting that was taking place. So has there been follow-up research? And I guess the answer may be obvious, but to show how the lighting actually affected nest success. Were the nest further from the light more successful than the nest closer to the light? And part two to this question is, can this study be generalized to other nesting shorebirds? Because we have nesting shorebirds here on the East Coast, for example. We have black-necked skimmers, we have least terns, which are very commonly nest here. Oyster catchers, I'm just wondering if this research can be kind of generalized, and if we can
Great.
take it here.
Yeah, great question. So the godwits are a wet meadow species. And so this was a study done in the Netherlands, and the road goes through a big, wetland. And yeah, I don't know about the follow-up on nest success. So I just don't know the answer to that. Is it generalizable that we should be concerned about light and shorebird nesting? In my view, yes, because the principle is pretty clear. It's about being visible to predators at night. And so if you've got to be on the nest and incubating, now some species are so cryptic that they can hide. Okay, that's great. But I think that I would certainly argue for the need to try to hit standards for development around things like this. And in fact, the study that I did on Western snowy plovers showing that decreased probability of it after a certain threshold, that went and was intended to and went immediately to the California Coastal Commission so that they could use it in their permitting of coastal development, right?
Okay.
And however, I will acknowledge that is one of a few and now emerging studies that actually get to a threshold number. There's a lot of things that are just like, that don't necessarily get you to something that's measurable and actionable on the ground in the regulatory context. So I think we'll get much more of that over the next 5 years.
Okay, because I'm sure that's a critical issue with development encroaching on wetlands and more light pollution, of course, in those wetland breeding areas, and of course also on coastal areas where development just can't gobble up enough land. So yeah, so that would be really important. And I know our efforts here to monitor shorebirds, and we see the predation from other wildlife, and it got me thinking when you mentioned the increase in lights adding to predation. That's probably what's happening here as well, because the predators are able to see the prey better.
Yeah. Yeah,
anyway,
I mean, it's no excuse for other things as well. I mean, all these are complex, interacting and synergistic issues, but,
right.
It's just the whole thing is the recognition that nature evolved with patterns that we have completely obliterated, and the degree to which we can restore them is going to be better for the system.
So I have Tanya Baker says, fabulous talk. Thank you. Is it okay if we contact you via email regarding potential neighborhood and municipal projects we may be trying to undertake on this lighting issue.
Sure.
Okay.
Longcore at UCLA.edu.
So that's Tanya Becker. I'm sorry, Tanya Becker. Okay. And Ronaldo Messon says, excellent presentation. Thank you for sharing so much relevant information. And I just want to thank you also. That was a brilliant presentation. It was so informative. I mean, forgive the cliche, enlightening. We really appreciate you taking the time to visit with us and present to us. And perhaps someday we can have you back, perhaps to expand on this topic in other directions as well.
Very well, thank you so much. I really appreciate it.
Okay, thank you so much. Okay, everyone. Thank you so much for being with us tonight. And thank you to our great team. And from left to right there, Amaline Cook, Mark Slifkin, Autumn Quixote, Natasha Warich, Mary Young, Sharish Cook, and Sabina Begg, who leads our programs team that help bring you these virtual presentations. And we can't wait to see you next month on June 4th for our next presentation with Dr. Steve Davis of the Everglades Foundation. So be sure to join us next month for another great presentation. And we look forward to seeing you then. In the meantime, have a great evening. Have a great month of May. And we'll see you in June. So good night, everybody. You take care.